Good afternoon, everyone. I'm Kiran. With me is Selva. We both are from VMware, India. Today we're going to take you all through the extreme data-driven testing framework for Java, which we have written, and this has been getting used in one of our QA teams currently extensively. Okay. So the agenda of today's session is mainly we'll explain about the testing evolution, how it happens, analogous to the human beings evolution into different ages. And we'll explain the limitations of existing Java testing frameworks currently we have. And then we'll introduce to our extreme data framework. And then talk about the advantages of it, how it is, and how it works. And then give the future directions, what are the plans we have for the future of this framework. And we'll go with case study and demo, and then we'll be open up for the question and answers. Okay. I hope everyone is from testing background. So how many of you guys are still in this age? Oh, very less people. So that's right. That's great. Okay. So Stone Age testing is like manual testing. There's literally no automation existed in early ages of early times of testing. It was very time-consuming, and it's kind of eyeball testing. It depends directly on the person who is testing. If you give the same test cases to execute to other tester, it will be like he'll have a different view of, or he'll give a different results maybe. You don't know. It's less predictable. And it's cumbersome and it's costly to do it because, again, it depends on how you execute it, and you cannot actually do a regression of it. And it varies depending on the people who do it. And tools, if they were existing any, were not used so efficiently. It's like we had scripts, and then it was not written to do an automation in that time. So, yeah. So next, testers started writing test cases or automating the test cases. That's when we actually enter into the bronze age stage. So we have a lot of test data hard-coded in the test scripts directly, and then we have a lot of script to maintain. So let's say I'm testing some piece of code with 100 test cases. If I want to add 10 more scenarios into it, you need to add another 10 or 15 test cases into it. It's like, it keeps multiplying with the new features which you add. It's kind of semi-automatic, and very small part of it is completely automated. That means we have, let's say, take an example of a test script. Let's say somebody has written a test script, 100 test scripts to verify the software. And then we'll say, OK, how do you execute it? So we'll come back and say, OK, you run this script, and then it'll get executed. OK. When we take a look at the log file, say, OK, there is no way you can actually see what test has passed and failed. There is no standard automated way of checking whether it's working fine or not. And this is the time when the test frameworks like JUnit were born. That is, we have JUnit wherein we used it for unit testing and then limited functional test cases. Okay. So Iron Age is the stage wherein the tests are all automated completely, and then we said, OK, we are 100% automated, and we are done with it. So this is the age where we have powerful testing frameworks like TestNG at testers' disposal. And the automation is there to some level, and data-driven testing is supported out of the box by many frameworks. So this is a typical conversations we can go through. The manager asks, OK, great that you automated all the tests. OK, can you show me how it is? Engineer says, yes, here is the Excel containing all the combinations of data. That is, we have 8 data. Let's say we want to create a machine with 1 and 2 CPUs, and then 1 gigahertz of RAM and 2 gigahertz of RAM, GB of RAM, and 2 disks, maybe like 100 GB and 200 GB. It will add to 8 data which you just need to enter in the Excel sheet. The test would do the required things. Then the manager say, OK, that's great. So in the coming release, we want to support 1 to 8 instead of only 1 to 2 CPUs. OK, I'm an engineer. I'll say, OK, it's simple. We have to add only 32 rows in the Excel sheet. OK. Next thing again, the manager says, oh, that's fine, but you have to handwrite the data. But we are planning to support till 8 GB memory. So then if you do the math, it takes 128 rows of data in the Excel sheet, which again, you need to enter manually. Is there a better way to do it? So I'll say, okay, I'll get back to you and think over it. I'll say, okay, fine, and then what needs to be done if you want to support 2 more NIC cards? That is, I need to add one NIC card and 2 NIC card into what machine you are going to create. So then, okay, I need to add an extra column to the Excel sheet, and then I do the parsing code, and then yes, we have to enter 256 entries into the Excel sheet. So the manager says, okay, immediately go to an extreme data-driven testing session in ISTA 2013. That's where we're going to explain how the data generation works. So this is, as we actually wrote all the automation code and everything is ready, everything is 100% automated. But this automation actually has given rise to a lot of new problems in automation. For example, whatever example I given previously is like generation of capabilities. You just need to add more and more data manually. There is no standard data generation mechanisms available, at least in open source as of now. And there's no standard data management. That means one tester will write the test data in a CSV file, another person will write in an Excel sheet, and some more people will actually get the data from the DB. And all these tests are different, and there is no direct, let's say if you don't want to get it from the DB, and then if you want to just get the test directly from an Excel or XML sheet and then use it, so there's no standard mechanism currently available to do that, and how you organize the data also. And there are a lot of problems which arises when the product evolves. So generally, it will not be a version 1.0 for all the products. After 1.0, you will get 2.0, 3.0, like that. And new versions will add more capabilities, as well as they will start not supporting different capabilities of the product. In that case, for example, there are some test data which were applicable in version 1, but in version 2, we need to support 20 data for which we need to test. But out of the previous 10 which existed, we won't support 5 of the data. So how do you go about writing the test? There is already a test, there is already a file. If you want to add the new things, and if you want to run it against the latest version of the product, what happens is you'll end up running all the old test data as well into it. So to do that, you need to again divide the files or divide the data files, give a different data files to the test, or a lot of workarounds need to be done. And let's say if we have a test which takes 100 data, and for some particular bug fix, you want to run only 10 of the data sets. How do you run it? So you need to run all the 100 and then see whether these tests have passed. Or we need to delete those files and then do modify some code to just run only those set of data. These are all some of the inherent problems which comes with the product evolution, wherein tests won't be able to cope up with the evolution of the product. Yeah. So we are on the new age of, it's called extreme age, wherein we have solutions for the most of the problems which we have discussed till now. And it's a generic framework. That is, it doesn't actually tie up with a particular framework like TestNG or your own internal harness which your company might be using, or JUnit or something. It is very generic. You can plug in into any of the frameworks. Particularly, it's written in Java. And and it is pluggable. That is, all the components in it are pluggable. It follows a standard workflow to actually do the work. That is, you specify the data first. You can generate the data, you can filter the data based on different needs, and then you can consume it in the way you want. So it has data generation techniques, yes. So that is already supported. We're going to discuss that in the further slides. And it mostly concentrates only on the test data, not on its source. So it actually shields the tests and then its data consumption in a way that you can give any data in a standard format, it will consume and then give you. So if you want to change some format on the other end, back end, you can always change it. The test will not be changed. And it allows reuse of test cases data across the different tests. That is, you need not write the same set of data to be provided into different tests if the same data will be run on different scenarios. Yeah, it solves all the inherent problems I explained before when the product evolves. Okay. Yeah, so next, Selva is going to take you through how it works. Yeah, after Selva.
Excuse me. Okay, so here is the overview. So DD code takes the class name and the context as the input for getting the data. So first it takes the class name, gets the data, processes the data, and filters it, and creates test instances based on the given data, and it returns the list of test instances with their data to the harness. So now harness can execute these tests in their own way according to their need. Let's see the framework in detail. See, the harness sends the class name and the context. So the data supplier searches for the data from its source, and it returns the data in the form of high-level configuration. That is used extensively in the DD core framework, which is of Apache Commons. So then DD core checks whether you want to generate the data from the combinations or not. If data generator is to be used, it will just use the data generator, and it will generate the combinations. Then DD core combines both generated data and the handwritten data if you have, and gives it to the filter chain. So filter chain is nothing but like list of filters to filter the data based on different criteria. So that we'll discuss later. So then the filter data, DD core takes the filter data and creates test instances using instance creator, and data injector injects the data to every test instance, and the final output from the framework is list of test instances with their data, which directly test runners can use it. Let's see the models in detail. So first comes the data supplier. So the data supplier is responsible for searching the data and return it as hierarchical configuration. Let's see the example of XML data supplier, which is the default implementation in the framework. So XML data supplier searches for the XML file name from the class path in the following order. So first, it checks for the fully qualified class name.xml from its class path. If found, it will just go ahead with that. Otherwise, it will search for the package name.xml. If found, then it will just pass the data and give it as hierarchical configuration for further processing. So let's take this example. It has data-driven.test1. So data-driven with this test class, so data supplier searches for data-driven.test1.xml, which is not there in the class path. So it goes ahead and searches for data-driven.xml, so which is very much available. So the data-driven.xml will look like this. Anyway, it's transparent now. It's not visible. OK, so it has namespace, class name, and list of data for consumption. So the data supplier parses all the data and return it as hierarchical configuration to the framework. So next comes the data generator. So data generator generates the data from the given combination information. So the combination information takes the following format. It starts with any root, which can have data combination, and data combination can have one or more sets. A set can have one or more elements. So element can have user-defined properties. So users can enter their own data here, but this structure is actually fixed. So then generator takes this data and generates the combination by actually combining elements from all three different sets, and it generates all the data like this. Let's see the example of first one. So first data got generated by combining first element from all the three sets. Like this, it will generate all the data. So our framework now has two different data generation techniques. First one is exhaustive. So exhaustive generator generate all the combinations for the given properties and values. Let's take this example, so which has A, B, and C as properties. So A has 2 values, B has 3, and C has 2. So the exhaustive generator generates all 12 combinations like given here. The second one is pairwise generation, which can be used for a different need. For the same example, A, B, C with the same properties, pairwise will generate only 6 combinations. It will create only subset, but still it will cover most of the scenarios. So this can be used for maybe I want to just verify the correctness. If I want to do sanity testing. So like this, that time we can just generate only the combinations with pairwise, and actually go ahead with our testing. Okay, next is filters. So filters are defined to filter the data based on their criteria. So here are the sample filters. So first one is like test ID filter, which filters the data based on the given ID. Then version filter based on the product version, where actually against where the test is running. Then the property filter filters the data based on property name and values. Like this, actually, users can define their own filters according to their testing needs. So for the given data, we'll see how the filters works. So the first data will get filtered by the property filter as it has OS as Win, but which will allow only OS as Linux. Then the second data will get filtered by the version filter as it has only a version as 4, but this will allow 5 and above version. Then third data will get filtered by test ID filter as it has ID as 6, but test ID filter will allow only from 1 to 5 and 10. So all this data will go through these filters. The final result from the filters will have only one data in this case. Okay, now the filter data is ready for consumption. So we'll see the consumption part here. So consumption happens in 2 stages. First is test instance creator, which is responsible for creating the test instance for the given test. Then the data injector is responsible for injecting the data into the newly created test instance in their own way. So we'll see the example here. So the example is test 1, which is having member as data, which will get injected by the data injector. So here, if you have n number of data from 1 to n, and test class as test 1, instance creator will create instance for test 1 for all the given data, that is n instances, and data injector will inject the data into all the instances, and the final result will be the list of test instances with their data, which can be consumed by the test harness. Okay, let's see how to integrate the DD core with any framework. So it's very simple. So you can just get the Extreme DD jar and its dependent jars, configure the components according to your need. So you can have custom implementation for all the components, and you can just register them using components.xml. In case of TestNG, we use AtFactory to hook this data-driven testing framework. So with default configuration, users can write the test and XML in the same package, and just run the test, everything will work fine. So data will get injected as data member, which can be directly used by the test. Okay, I'll hand over to Kiran.
Okay, so now that we know what is Extreme Data Framework, let's go through the advantages of it. So mainly it provides automatic data generation, exhaustive and pairwise, which will help you to generate any amount of data you want for your tests. It uses a pluggable architecture. Any of the pieces of the framework can be configured and then written. Let's say if you want to actually write a filter for your own specific needs, and if you want to write test case based on that, you can always do it. We can get more coverage with less tests by implementing other pairwise algorithms like pairwise or orthogonal arrays based implementations for generation. And additions and deletion to the test is very easy. In case of data generator, if you don't want, if you take the previous example, if you don't want to actually support a CPU with a number of 8, you can actually delete that data directly and then generate the next set of generate the data directly from the generator. That is, modifications into the test data is very easy, and then it doesn't actually result in any of the problems generally we face. And when we actually consider Extreme data-driven testing while writing the test cases, we can actually combine many test cases into one, that is writing test scripts. Let's say we want to write tests, there are 10 tests which you want to write. If you go through all the tests and then see the commonalities across, and then see how we can actually apply this framework into it, it can be reduced to 2 or 3, and then the remaining data can be fed directly into the test directly. It would reduce the cost involved in actually doing it, and then time it's required to actually develop it, and over a period of time, the maintenance of the test scripts and the data will be less. Yeah, so in VMware, we currently use the default supplier, that is XML-based supplier, and it has a lot of advantages. We thought, okay, we'll share with you all the real advantages we are actually reaping by using XML configuration. So there's no hard coding of the file location of the file. Let's say if you have a test script and then you said, okay, this is the file which you want to pass into it, you need to write it somewhere. So, but in this case, it's all based on class paths. We search by default as Selva explained, we search the files and then directly, and then if you look at the file, we read it and then source the data into the test directly. There's nothing required to actually write it explicitly. And any type of data can be passed into the test. That is, let's say your test takes a list of data. You can directly add it into the XML under the name called element or under the data, which will be directly passed. Whatever you enter will be directly passed into the test. There is no need for any parsing or anything which is required. That it's very flexible. And yeah, so the data is directly available across the test. You have the test and you have data together. It's not in separate DB or somewhere where you don't know where the data is. You can directly open up and then see. You can directly relate the tests and then data. You can, if you just open, okay, there is a positive test. If you open it and then see what's the data it's consuming, it's very straightforward to see what's happening with the test. And there's no single point of failure. Like if you're having your data in a DB, if the connection is not there, then it will not, you will not be able to execute your test. Here, the data will be local, and there's no point, that problem won't ever arise here. And we can see the history of data. Let's say you have a product which is run from version 1 to 10, and then you have written a data-driven test for it, and you have the XML file with you. You can always see how the data has changed over a period of time, and then understand how the features have changed, and then you can even revamp how you are doing your testing. Okay? Yeah, so going further, we're planning to add more generation capabilities into it, like orthogonal arrays and sampling-based generation, etc. And we're planning to enable priority-based data generation. That is, when you are actually generating using OA or sampling, you need to give a lot of weightage to some of the data, and then you may not actually consider some data which as important. That type of weighted generation we're planning to add, which would help us to actually get more coverage, and then we can stress the features which we want to test properly. And we are trying to enable link XML files. That is, currently the sharing of the data is only in the package. It's not across packages of the test. That is, we are planning to actually do that across packages sharing of data. And we're planning to push this framework into VMware repo as of now. It's currently available in GitHub. Okay. So the case study is like, we have been using this framework for almost 2-3 years for testing the vSphere features. vSphere is the flagship product of VMware for virtualization. So let's take a few features wherein we actually used it extensively. Guest customization is a feature wherein you can, whenever we actually deploy a virtual machine, we need to customize it to set some IP or DHCP network settings or any other settings you want to put before you actually create a VM, and then do a customization for that. So approximately, we have written 70 test data classes, and which actually takes 1,200 test data. Some are generated, and then some are handwritten depending on the scenarios. So that means for every release of new OS, let's say we get a new Ubuntu version for which we need to do the customization, we just add the data into we just add the data in the XMLs. That's it. There are 70 new test data. We'll add it. There is no change to the test cases at all as such, but we have added 70 test cases into it. So that's the way in which we are currently doing the test customization, and it has reduced a lot of time. We need to invest into writing the new test cases. And vMotion. vMotion is a feature in vSphere again, which allows you to migrate a VM from one machine to another machine, that is one ESX to another ESX. And it has actually gone through a lot of changes across versions. We've taken 2 examples here. Version 1 was used to run with 300 test cases. And in version 2, there was a new feature added to support one more parameter or one more option into it. So there, we just added another 160 test data into the existing files, and then we have not touched the test code at all. So that has enabled us to directly say, okay, this feature works for this particular scenario. And we added a few more new test cases which are very specific to the new feature into it. So vSAN. vSAN is a new release which is done this year. It actually enables of using local SSDs in the system as a storage area network. And we have around 50 test cases which are powered by 900 test cases in this case, which are all generated. So if there is any, So this is a sample XML which you have used, which are in currently production. You can see these are all the, can you read it? Is it readable? Or, okay. So this is the XML structure we have used. Maybe we're not able to understand the data which we are providing, but if you can see there are 3 into 2 into 3 into, there are 54 data sets which will be generated by just this specification. Think of if you want to write all those combinations by hand. And this is all the sample data which will be generated, and then yeah, one of the elements as explained in the data generation. Yep. So we'll be showing a demo of how it is. Yeah, right. The source code is available in GitHub. You just need to clone the repo to your local repository. So currently, I have already cloned it in my local repository. I'll directly open the Eclipse wherein I have the details. Okay. So first, let's take you through the configurations file so that we know exactly how we can configure it. Under main resources, we have a file called datacomponents.xml. So here is where, can you guys see it? One second, sorry. Okay, it's okay, right? So this is the main configuration file by which the framework works. That is, we can define all the suppliers. In this case, we have a default supplier as XML data supplier, and we have a CSV, simple CSV parsers which we have written. And the generators will be configured here. Currently, we have two implementations, the exhaustive and then pairwise. And default is the exhaustive generator here. The filters, we have the test ID filter and then priority. Like this, you can configure any of your classes. If you plan to have your own implementation, you just need to actually write the implementation plugin here. So this is the main configuration file, by which you can control how the framework behaves. Let's take a sample test and then see how it works. Here we will see how the data generation works, and in this case, in this test, we will just test a simple additions, add and delete of entries into a test list. That is a list implementation. Okay. Let's directly go into the XML first, and then see how it is. If you see here, the data, this is the test class, that is dynamic usage.java is the test class name. And we have a file called, where is the file? Dynamic usage.xml, which will be automatically found. And this has the entries for different values. In this case, we have written data combinations with sets. This will actually generate capacity of the list can be used here. So the capacity actually specified. There are two capacities we are given. Initial capacity of a list with 20 as the value and then 50 as the value. And the next thing is number of items to add into the list. I'm going to add 100 once, and then in the next test, I want to add 50 element, 500 into it. And then items to remove is 10 and 50. So now let's go back to the test. Here, hierarchical configuration data is the member which we need to write, and then the data will be directly indexed into it. This is a simple map kind of thing, but it's more advanced. It has a lot of capabilities. In this case, here, if you come to the setup part, I'm going to just say data.getInt. I want to get the capacity, and then items to add and items to remove. So we have all the elements into it. We'll just log it, and let's coming to test. Coming back to the test. The test, we will do addition depending on the items to add which is given, and in the we'll just check whether it's working fine, and then we'll do a removal of the items in the list. Yeah. So, and there is one more thing which we need to add in your test. This is with respect to test-ng. Here we have a @factory which will actually source the test instances directly in test-ng. So the test-ng is the harness which is going to run the test cases. Here there is only one line which we need to add, that is readyhelper.getTest for this particular class name. And if you want to pass some parameters into it for any of the configurations, you can directly pass it. The only thing which you need to add is the class name and then context, and then write this method. This will give you all the features of Extreme Framework. So now let's run the test case.
Yeah.
Can you maximize console? Console.
No. Yeah, I'll go with this then.
Yeah. Okay. So here, it has run total 12 test cases. It has generated 12 combinations dynamically, and it is used it. And if you go, this is very simple. That's it. So this is what we just need to do to actually run a test using the framework. Just add it, and then dynamic usage is the class which we have. Yeah, I think that helps, right? Anything else? Yeah, go back. Oh, just go. Okay, I think that's it from our side. Thanks, and then we are open up for the question and answers. And we have a book to give out for interesting questions, if any. Yeah, so we understand it is post-lunch session.
Oh. I have a question about the filters in your framework. We saw that you generate basically all variants or pairwise variants of the test combinations of the test data. But do you have some way to filter the invalid combinations? Do you have some conditions which can be input along with the data, and some data which cannot be combined with others simply to be ignored?
You mean to say when you want to generate, you don't want to generate some of the data sets in the from the generator?
For example, you have 2 elements, and the first one has two variants, the second one has 10 variants, but the first variant of the first element works only with the first variant of the second element. Then you don't need all variants, but you need only one variant combination.
Yeah, yeah, I understand. So for that, okay, you can go back to the XML data combination. So this is a very specific thing. That is, you will work only with subset of all the combinations. That's it, right? So in that cases, we can actually enter the data combinations. We can separate out. For example, in this case, if you don't want the second capacitor to work with all the other things, we can remove it and then create another data combinations below this, and then add that element, and then add the data sets which can work with only that particular set. That would generate the data sets only based on this and the next set. That would actually reduce less number of data sets, but yeah, so that problem will be solved. You can add multiple data combinations depending on the requirements.
Okay, thank you.
That answers? Okay, thanks. Okay, any questions? Okay, thanks a lot. Yeah. Sorry, I think, yeah, so the book goes to the only one question we had, so yeah.